Hello everybody, source transformation theorem. You can see a picture here, there is an voltage source, it's being converted as current source or vice versa. So current source can be converted into voltage source can be converted into current source, vice versa. Because in some circuits you will find that converting into either current and voltage source makes the problem simpler. And therefore the transformation from source, that is voltage source, to current or vice versa is needed. This is called as source transformation theorem. How do we do it? Let's understand. So let's take one example. You see here there is a voltage source is converted into current, and in the second case, and it depends on, it's applicable to both independent sources as well as dependent sources. So if I see here a voltage source in series with resistance, now it is converted equivalently to a current source in parallel with a resistance. So what will be the current? Current will be nothing but Vs divided by R, right? Is is equal to Vs divided by R, or we can say Vs into R. Vs is equal to R into Is. So source transformation theorem is a process of replacing a voltage source in series with a resistor by a current source in parallel with a resistor, or vice versa. So here also you can see. So this is so simple. Source transformation cannot be applied where R is 0 for the voltage source and R is infinite for the current source. It means there must be some value of R in case of voltage source. There must be some smaller value of R for current sources. It must not be infinite and it must not be 0. So there must be some resistance. Otherwise, how will we calculate the current value from voltage or voltage value from current, vice versa equivalently? Therefore some small value of resistance in voltage source and some value for resistance for current source is needed, then only we can do it. Otherwise it's not applicable. Again, suppose there is an example, source, voltage source in series with resistance. How will you calculate the current here? Vs divided by R. So look at here, Is is nothing but Vs divided by R. The same resistance becomes in parallel with R. If you remember Thevenin and Norton theorem, this is equivalent to Thevenin equivalent circuit and this is equivalent to Norton equivalent circuit. Norton equivalent circuit, is the circuit where you have the entire network can be replaced by a current source in parallel with resistance. The Thevenin equivalent circuit says that the entire big network can be converted into simple single voltage source in series with resistance. So this is exactly happening here, where Vs is equal to Is into R, or Is is equal to Vs by R. The relation between I and V must be linear again. This theorem is also applicable in the linear network where the elements are linear. Let's understand by one example. You see here there is a problem where, say, we are interested to calculate VO, that is voltage across 8 ohm, and let's apply source transformation. So as you can see that the first one, let's convert this 3 ampere as a voltage source. So you see here minus plus because direction is down, right? So it is minus plus 12 volt. Similarly, and again what we can do, we can apply the source transformation theorem to here. Now 4 plus 2 is 6. So 6 in series with 12. Let's again convert into current. So 12 divided by 6 is 2 ampere. This 6 is in parallel. Now same you see here. Now this is the voltage across 8 ohm we are interested. There is a current 4, opposite direction 2. So there will be effective one current source of 2 ampere, upward. What is the resistance? 6 and 3 are in parallel. So 6 and 3 parallel is 6 into 3 divided by 9 in 2 ohm. So this becomes very simple. So what will be the current now through 8? That is nothing but 2 divided by 2 plus 8 into 2. So you can calculate current and multiply by 8. So 2 divided by 2 plus 8 into 2 is 0.4 ampere, and multiply by 8 will give you the voltage across, this 8 ohm is 3.2 volt. So this is so simple. And say when we are interested to calculate, in case when there is a dependent source, almost same rule you see here, we are we want to calculate by this one. So you see here this voltage source is converted into current source. So 2 has become in parallel, and you see here 3 and 2. And now again this, this 2 and 2 in parallel will become 1. So 3 ampere and 1 ohm will become 3 volt, and 1 in series. Vx will remain there, 4 ohm, and this is Vx and 18. So we can write down one equation, 3 is equal to 1 into I plus 4I plus Vx plus 18. Second is nothing but, you see here, Vx is equal to this 3 and this I is nothing but 3 is equal to 1 into I plus Vx. So there are two equations. Look at here. The first one is minus 3, plus 5 by, this is total 1 plus Vx plus 18 equals to 0. And we can just use the second equation, minus 3 plus I plus Vx equal to 0. Solving this two, I is equal to minus 4.5 ampere and Vx is 7.5 volt. So whether there is a dependent source or independent source, we can calculate the voltage across a current through using the source transformation. So you can convert voltage into current or current into voltage wherever, whatever is needed, and we can solve the problem. So this is also very useful and important theorem in circuit theory. Thank you so much. Hope you like this video. If you like this, we'll do more and more number of problems using source transformation theorem. So please do not forget to subscribe the channel and share with your friends and peers. Thank you so much. Good luck.